Assalamualaikum and hello everyone. My name is Muhammad Haziz bin Muhammad Zaini. Now our group will present MAT 183 video presentation. We would especially want to thank Sir Shahrul Heri. Without Sir Shahrul and my friend, it will be impossible to complete this project. So, our topic is Application of Differentiation. What is differentiation? Differentiation is a technique for determining a function derivatives is differentiation. Mathematicians use a procedure called differentiation to determine a function instantaneous rate of change based on one of its variables. The rate of change of function is defined as dy over dx equal fx equal y. So, for the next, when do we apply differentiation? For number 1, to calculate the profit and loss in business using graph. Number 2, to check the temperature variation. Number 3, to determine the speed or distance covered such as miles per hour, kilometer per hour. And number 4, derivatives are used to derive many equations in physics.
Application of differentiation. What is application of differentiation? The differentiation is the subfield of calculus, and there are various applications of differentiation in real world. The differentiation is very important part of math, as it is used in many scientific fields. Differentiation can be defined as the process of finding the derivative of the function. Differentiation has a wide usage in real life. A few applications are in business and for calculation using graph. What are other applications of differentiation? There are few other applications of differentiation, which is related rates, graph of polynomial functions, graph of rational function, applied maximum and minimum problems, Rolle's theorem and mean value theorem. What is related rates? Related rates problems involve two or more variables that change at the same time, possibly at different rates. The idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity. The procedure is to find an equation that relates the two quantities and then use the chain rule or implicit to differentiate both sides with respect to time. Here's a problem statement. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cm3 per second. How fast is the radius of the balloon increasing when the diameter is 50 cm? To solve this problem, we need to sketch the diagram first. Then we need to identify the things given and the things needed. The volume is increased at a rate of 100 cm3 per second. So the dV over dt is 100 cm3 per second. Then we need to find the radius of the balloon increasing when the diameter is 50 cm. So the dr dt, we have to find the dr dt when the diameter is 50 cm. So when the diameter is 50 cm, the radius is 25. Next step, we need to solve using chain rule or implicit. Here we are going to use chain rule, which is dr over dt equals to dv over dt times dr dv. So we need to know the formula for spherical, which is v equals to 4 over 3 pi r cubed. Then we need to differentiate v with respect to r, which is 4 pi r square, and then we need to rotate its form from dv dr to dr dv, which is 1 over 4 pi r square. Therefore, the dr dt is 100 times 1 over 4 pi r square. and then we need to substitute the value of r, which is 25. Then we get 0.0127 centimeter per second.
Let's find dr per dv. We can find dr per dv from differentiate the formula v. So after that, we get dv per dr equal to pi times 4 times pi square. After that, dr per dt equal 2 times 1 per 4 times pi times r square. After solving the expansion, we get 1 per 2 times pi times r square. And after that, we substitute r, which is equal to 3, and we will get 1 per 18 times pi centimeter second. As for the conclusion, what can we get from this topic is an understanding of related rates or rates of change problem involving geometry, formulas, and functions. Also, we can solve the related rates problem using the chain rule method and implicit methods. Thank you.
Hi, I am Arifan. Right now I will explain to you all guys about objective graph of polynomial. So the first objective is to determine critical point and the intervals where f is increasing and decreasing. Secondly is to determine the inflection point and the intervals where f is concave up and concave down. Okay, right. And now I will explain a question about graph of polynomials. So given f(x) equal to x plus 2 times x minus 2 square. So determine if any. The first one is the interval where f(x) is increasing or decreasing. Second one is the extreme point by using the first derivative test. Third is the intervals for concavity. Lastly, the point of inflection. The first question asks about the interval where f(x) is increasing or decreasing. So what should we do is do a first differentiation, and we will get 3x squared minus 3. And then at equation point f prime x equal to 0. So the equation will equal to 0. Then what should we do is factor the first differentiation, and we will find the value of x. So the value of x is x equal to 1 and x equal to negative 1. Then we will sub in the value of x in fx, and then we will get the point of y. So we will get the coordinate. So then we have to using sign analysis to identify the graph is increase or decrease. After that, we will get increase on negative infinity, negative 1, and 1 plus infinity, and decrease on negative 1, 1. So for the second question, as about extreme point, so we have to look at a table, sign analysis table. So we get that in that coordinate 1 0 is relative minimum, then negative 1 4 is relative maximum. For the question 3, as about concavity and inflection point, what should we do? If do a second derivation, and we will get cs. So cs equal to 0. So we will get s equal to 0, and then we saw the value of x 0 in fx. So we get, then we do a concavity test, and then we will identify that the function of f is concave down on negative infinity 0 and concave up on 0 positive infinity. So the point of equation is 0, 2. The question about graph of polynomial. In conclusion, polynomial are an important part of the language of mathematics and algebra. They are used in nearly every field of mathematics to explain number as result of the mathematical operation. Programmers are also building blocks in other types of mathematical expressions such as rational expression. So that's all for me. Thank you.
Thanks for watching. I hope you all guys can understand our explanation. Thank you.